Okay, this lesson is on trig graphs, and the first graph that you can see is y equals sine x. And the values, the coordinates here match up with what you already know about the unit circle. So you know that on the unit circle here, sine of 0 is the y coordinate, which is 0, and you can see that 0 just here too. Up here, sine of pi on 2 is 1, and you can see just here, sine of pi on 2 is 1. Coming around here on the unit circle, you've got sine of pi, the y coordinate there is 0, and you can see here on the graph as well, sine of pi is 0. Just in the middle here is 3 pi on 2. Coming around here on the unit circle, 3 pi on 2, sine of 3 pi on 2 is negative 1, and you can see that's negative 1. And then back around here to 2 pi, and sine of 2 pi is 0. You can also see that the y equals sine x is an odd function, which means it's got point symmetry about the origin there. So the domain, what is the domain of sine x? Well, it is all real x. Oh, I think I like red better. And the range, well, you can see that the y values, it ranges between 1 and negative 1. So you can write that as y is in between or equal to negative 1 and 1. The graph of y equals sine x has period. Okay, so that means how often is it repeating? So if we're starting here, it starts to repeat again another period there. So the period is 2 pi. And amplitude is how far up it goes there. So you can see the amplitude is 1. The amplitude is always going to be a positive number, even if the graph is flipped. Alright, but if we had a general curve y equals a sine nx, then the period is going to be 2 pi on n. This is when we start making modifications like enlargements or shrinking or moving graphs up and down. This is how you can work out what the period is going to be. So it's going to be 2 pi on n, and the amplitude is whatever number's at the front here. So the amplitude is going to be a. Have a look at a few equations and then we'll graph some. So the period of sine of 4x is 2 pi on 4, which simplifies to pi on 2. And you can see the coefficient of sine x is 1, so the amplitude is still 1. The period on the next graph, we can see the period is just going to be 2 pi, because it's exactly the same as y equals sine x. This is imagining there's a little 1 in front of that x. Oh, that wasn't quite right. Let me rub that out. There we go. And the amplitude is just there. The amplitude's 4. The period on the next graph, on the next curve, is 2 pi on 2, which simplifies to pi, and the amplitude is half. There. Period on this graph here would be 2 pi on a quarter, and that becomes 2 pi divided by 1 on 4, which is 2 pi times the reciprocal, which is 2 pi times 4 on 1, which is 8 pi. And then you can see the amplitude, you're still going to say it's positive too. This negative just means that instead of the graph going like this, it's going to be flipped like that. You'll see that when we do some examples. Alright, so the first graph here, then before you graph any trig functions, it's always good to do a little bit of working out and to write down on the side what the amplitude and the period is going to be. So you can see the amplitude of this graph here is going to be 2, and the period is going to be 2 pi. So we could say maybe this marking's pi and this marking is 2 pi, which would mean this one here is pi on 2. You got 1 pi on 2, 2 pi on 2, 3 pi on 2. That's how you work out those fractions. And then that's going to continue. If that's pi, that's 2 pi. This would be 3 pi. That would be 4 pi. And going backwards, that's going to be negative pi, negative 2 pi, negative 3 pi, etc. Alright, then using a ruler, muck in a measurement there and there, which are the same length. Then because our amplitude's 2, we can just say that's 2, and then that's -2. Now to graph our curve sin x, sine of 0 is 0, and the period here is 2 pi, so we know we're going to finish one period just there. In the middle it'll also be at 0, and we're going to put a little dot there, and then you just pretty much either using your math aid or connecting the dots, and you can do the same thing here, going back to repeat another cycle. And then because sin x is an odd function, you know that it's going to be going like this. Should I turn my notifications off? And it'll look like that. Okay, in the next graph here, we've got the amplitude is 1 and the period is 2 pi on 2, which will simplify to pi this time. So that means we're going to have one whole cycle or one period will be pi. So this time maybe let's put pi here at this little marking. That means halfway is going to be pi on 2, and half of pi on 2 is pi on 4. Should mean, so that's 1 pi on 4, 2 pi on 4, 3 pi on 4 would be the next one. 4 pi on 4, which simplifies to pi, etc. Alright, let's just going back. The second one would be negative pi on 2, and then the fourth marking along is going to be negative pi. Alright, now our amplitude is 1, so we'll make that 1. Down here, negative 1. Starting at 0, remember we're going to be finishing at pi because that's one period. Right in the middle will also be 0, going up here and down here. So that's how that sine 2x is going to look. Putting our little dots, knowing that it's an odd function and it'll look like that, and you can continue it in both directions or put arrows. Okay, depending on what the domain is of the of what you need to sketch the graph between. Alright, we've got y equals sine pi x, so the amplitude is 1. The period is 2 pi on pi, which simplifies to 2. Oh, this is a little bit different to the other ones. So now we're going to let's make that marking there 2. That means that one will be 1, etc. So that's -1, -2. And our amplitude is 1, so make that 1, make that -1. Alright, starting here down here, it's at 0, we're going up, back to 0, down to -1, and back to 0, because remember our period is 2, so we have one cycle. So there's our one period, our one cycle, and then putting our dots back in the other side. Oh, that wasn't very good, because right here it should be going through. It should be going through there. That's a bit better. Okay, so you can either, depending on what the domain is, you can either stop it there or continue in both directions. That was supposed to be an arrow. Okay, the next graph. The amplitude you can see is 4. The period is going to be 2 pi on half, which simplifies. 2 pi divided by half, just 2 pi times 2, which is 4 pi. So let's make this marking here worth 4 pi. That'll be our one period. Halfway will be 2 pi. Half of that will be 1 pi. So 1 pi, 2 pi, 3 pi. Easy way to work out our markings there. That's -2 pi, and then this one here would be -4 pi. Period was, our amplitude is 4, so we'll make that worth 4. And down here, same distance, -4. Alright, we're starting, sine of 0 is 0. Okay, we've got one period going here, ending at 4 pi, and the middle would be there. Just there. See how it's kind of the same thing for every question. Probably getting the hang of it now. Okay. Now at cos x. Now relating back to the unit circle. Oops, wrong button. Right here, remember cos x is the x coordinate. So cos of 0, you can see there is 1. So cos of 0 is 1. Cos of pi on 2 is 0, right there. Cos of pi is negative 1. You can see that's there. Cos of 3 pi on 2 is back to 0. And cos of 2 pi is 1. So you can see there is 1 period. And is this an even or an odd function? Well, you can see it's symmetrical about the y-axis, so it is called an even function. Alright, and what is the domain? What possible x values can this graph have? And you can see any x values there. So the domain is all real x. And what possible y values can it have? We can see the y values range between 1 and negative 1. So the range is y is in between or equal to negative 1 and 1. The period, you can see that repeated after 2 pi. Going from there to there, it's repeating. 2 pi. And the amplitude is 1. Same as sin x. Then if we have a general graph y equals a cos nx, the period is going to be 2 pi on n, just like sin x, and the amplitude is going to be a. So sin x and cos x are very similar. You can just see that cos x has been kind of shifted, I guess you could say shifted to the left by pi on 2. Okay, now work out some period and amplitude so that we can graph some of these functions. The period of cos 2x is going to be 2 pi on 2, which equals pi. The amplitude is 1. The period here is simply 2 pi. The amplitude you can see there is 2. The period here is going to be 2 pi on 4, which simplifies to pi on 2, and there's the amplitude, a quarter. And the period here is 2 pi on a quarter, which is 8 pi. And the amplitude is positive 4. The negative, remember, just means if that's y equals cos x, then negative cos x would be the blue curve. So it's just reflected in the y-axis. So that negative 4 means that you have a negative, so the amplitude there would be 4, so you could put even a marking there of negative 4, and that would be 4, for example. Let's have a look. So just like the other graphs, we are going to write down our amplitude and period before we start sketching. So amplitude is 3, our period is 2 pi. So let's make this value here 2 pi. That would be pi. It's going to be half of pi, which is pi on 2. 1 pi on 2, 2 pi on 2, 3 pi on 2, 4 pi on 2, which simplifies to 2 pi. Alright, our amplitude is 3, so let's make that value there 3. And the same distance down here. Whoops. Negative 3. And going back here, you've got negative pi here and negative 2 pi. Alright, so sketching this one, amplitude's 3. Alright then, Tamalaki. Okay, so we're going to start up here, and we're going to finish over here because that's where one period would be, 2 pi. Okay, we're going to come through 0 here, down to negative 3, through 0, and then back up there. So the graph is going to look a little bit like that. I mean, because it is a symmetrical graph, because it's an even function. Oops, it's not going to be down there. It's going to be there and there. Then that's how it would be if you were graphing it between negative 2 pi and 2 pi. Alright, the next graph here, the amplitude is going to be 1. And the period is 2 pi on 3. Oh, this one's going to be a lot different to some of the other ones. Now, we want our period to be 2 pi on 3. So let's put our period marking on the 4th marking along. That'll help us to then, half and half it again. So half of 2 pi on 3 is 1 pi on 3. And half of pi on 3, well, you know pi on 3 is 60 degrees, and half of 60 degrees is 30 degrees. So that is going to be pi on 6. And then to work out what the other markings are, you can kind of count up. That's 1 pi on 6, 2 pi on 6, 3 pi on 6. You can leave it like that if you want, or if you want, you can simplify that to pi on 2. 4 pi on 6, 5 pi on 6, 6 pi on 6, 7 pi on 6, 8 pi on 6, etc. Let's go back the other way. Down in the negative, the fourth mark, looking along, that's going to be negative 2 pi on 3. And we might just put this one in, which is negative pi on 3. Now amplitude's 1, so we might put 1 there and a negative 1 there. Now our cos x graph starts up here at 1. Our period, remember, is 2 pi on 3, so we're going to finish over here. We're going to come down to 0 and down to negative 1 there. So our graph is going to look like that. And because it is symmetrical, it's going to go through these values here. So there's the graph of y equals cos 3x, and we've got a domain there of between negative 2 pi on 3 and 2 pi on 3, but obviously it can continue in both directions because the domain is all real x. Graph. Now we've got the amplitude here, you can see, is 2, and the period is 2 pi on 2, which is pi. So let's make our fourth marking along pi, which halfway would make this one pi on 2. Half of that would be pi on 4. So pi on 4, 2 pi on 4, 3 pi on 4. And you can see as well, if we went to the next one, 4 pi on 4 simplifies to 4 pi. So that one would be negative pi, and that one would be negative pi on 2. Our amplitude is 2. We'll make that 2 and that value there negative 2. If you were drawing this in an exam, you can most certainly just draw the graph first, trace out your math aid, and then put these markings in. Alright, so we're starting up here at 2 this time, and we're going to be finishing one period over here at pi, when x equals pi, at y equals 2. We're going to be going down here to negative 2, here will be 0, and that will be 0. So there's part of the graph. Going back through 0, down to negative 2, 0, and finishing off. There is the graph y equals 2 cos 2x. Okay, our amplitude on this one here is going to be half. The period is going to be 2 pi on a quarter. Oh, sorry, that writing's not very neat. Which is 8 pi. Big, big, long period. So we'll make our period there 8 pi, which that's going to be 4 pi halfway. Half of that is 2 pi. So 2 pi, 4 pi, that's going to be 6 pi, etc. Down here would be negative 8 pi, and halfway there is negative 4 pi. Alright, our amplitude is half, so we'll make that value there worth half, and the same distance down here, that y value will be negative half. Cos curve, so we're starting up here at half. Our period's 8 pi, which means we're finishing over here at half. We're going to go through 0 there and finish and go down to negative half there. So, ooh, that's not a very good graph, because it is supposed to go through 0 right there. Very important. You may have the correct x and y intercepts. We're going through that point there, 0, and back up to half. And there we go. So there's a line curve. Okay, y equals 1 minus cos x. The amplitude is, remember the number in front of the cos x. So that's 1. The period is 2 pi. Now, this negative sign here means it's going to be flipped or reflected about the x-axis, and then this 1, it means it's going to be shifted up 1 unit. So to draw a graph like this, there's really a couple of other, I guess you could call it intermediate graphs that you'd want to graph first. I'd first graph y equals cos x. So we're going to draw y equals cos x, and we'll draw that in red. And you know the graph of y equals cos x is 2 pi. So what will this be? Negative 2 pi and negative pi. Sorry, my markings aren't really lined up correctly with those markings. We'll make that value there worth 1 and that value there worth negative 1. Alright, so our graph of y equals cos x is starting here, going down here, here, and it's finishing back up here at 2 pi where one period is. So let's just draw that one in. And we'll continue it down for negative x values, so through there, negative 1, through 0, back up there. Alright, I'm just going to label it. Very important that you label each of your curves if you are drawing intermediate curves. Alright, so we've got y equals cos x. Now let's reflect that about the x-axis and we'll draw y equals negative cos x. So, like that. So, that's not a very good bit. Y equals negative cos x. Alright, now the graph that we want to draw is y equals 1 minus cos x. So see how the only difference between these two graphs is you've got y equals negative cos x and then you need to plus 1. So we're going to take the blue curve and we're going to shift it up 1 unit to get our purple curve, which is going to be y equals 1 minus cos x. So we're shifting it up 1 unit. So every y value we're going to shift up. So that negative 1 will become 0, 0 will become 1. This y1 value there will become 2, so let's put a marking there for where 2 is. That will come down to 1 and this will move up to 0. So it's like we're just shifting the blue curve up 1 unit, and you can do the same thing over here and there. And then obviously that's going to continue in both directions depending on what domain you have to draw your graph between. Graph we're going to be doing today is y equals tan x. Now you can see in purple, what graph is that? Well, it's starting up at 1, so you can see the purple graph is y equals cos x. And the red graph is obviously y equals sin x. Because you can see for both of them the period is 2 pi. Why have I got y equals sin x and y equals tan x there when I'm supposed to be showing you y equals tan x? Because remember, tan x equals sin x divided by cos x. So to get the tan x curve, and this will help you to work out where the asymptotes are, you can see that whenever cos x equals 0, because cos x is the denominator, you know the denominator of a fraction can never equal 0. Whenever cos x equals 0, which was the purple graph, we're going to have an asymptote. So cos x equals 0 right here. So in our graph of y equals tan x, we're going to have an asymptote pi on 2, and also right here at 3 pi on 2. And then you can see also negative pi on 2 and negative 3 pi on 2. That's supposed to be a straight line. Let's do that one again. It's hard writing on this iPad. Okay. Then let's work out some other values here in the middle here. So we're always doing sin x divided by cos x to get tan x. So we're doing the red curve, the red y value, divided by the purple y value. So here we've got 0 divided by 1, which is 0. Okay, and then up here you can see we're going to, in this section of the curve, between 0 and pi and 2, you can see we've got a positive divided by a positive, which is a positive. And in this section of the curve here, we've got a negative divided by a positive, which is a negative. So that's why the graph of tan x is going to be negative here and positive up here. Okay. Similarly, I guess this section of the curve, between pi on 2 and pi, you're going to have positive divided by negative, which is negative. Right here, we're going to have 0 divided by negative, or 0 divided by negative 1, which is just 0. And then up in the next section of the curve here, this section, you've got negative divided by negative, which is a positive. So that's y equals tan x in purple there. And you can see that that's just going to continue. Another cyclical or periodic curve. And let's see where it repeats. So starting at 0, if we go up like that, and then come back here, you can see this part of the curve is exactly the same as this part of the curve. It's starting to repeat after pi units. So our period is now pi. Ooh, we've skipped a few questions. Let's go back. For what values of x is tan x undefined? Oh, so that's where the asymptotes are. So we covered that before. So that's right here. Plus or minus pi on 2. Plus or minus 3 pi on 2. Etc. The range of the function y equals tan x. Well, you can see that here's the range. It's going to continue in both directions. So we're going to say the range is all real y. We just talked about the period being pi. It's repeating every pi units. And so now when we're going to do modifications, our period then becomes pi on n. So the period of this graph here, tan 4x, is going to be pi on 4. So whatever the coefficient of x is really. Here it's just going to be pi on pi, which simplifies to 1. And pi on half, which becomes 2 pi. So, examples. And just like we did for sin x and cos x, we are going to work out the period and the amplitude. So, tan x, well, that's the one that we just did in purple. So, the period is pi. And the amplitude is all real x. So, because it's going to be, all real y. Because it's going to be all real y for every single tan graph. We don't really need to write that down as long as you remember that. Alright, so what will we have here? I think that first marking we had was pi on 2, then pi, then 3 pi on 2, and 2 pi. And going back the other way will be the same. That one is negative pi on 2. There, that's negative pi. Negative 3 pi on 2. This one would be negative 2 pi. So, mark in your asymptotes first. And, I forgot to mention this before, but looks like y equals tan x. Is that even or odd? It's not symmetrical about the y-axis. It's not an even function. Yeah, I'd say it's an odd function. It has point symmetry about the origin. And this is just going to continue. Alright, next graph here. The period is pi on 2. Remember the formula was just pi on n? Whereas for cos x and sin x, it's 2 pi on n. So that's one big difference there. Okay, so you know how in this curve here we put our period as the second marking along? We'll do the same thing here. We'll put our period as the second marker along. So our period is pi on 2. Half pi on 2 is pi on 4. So 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, which is pi. And going back the other way, that would be, first marker is negative pi on 4, negative pi on 2, negative 3 pi on 4, and that one's negative pi. We don't really need to put y values on our y-axis because the range is all real y. Alright, so there's going to be our asymptotes. If you set it up like this by putting that period, working out the period and putting it on the second marker, then you know where your asymptotes are going to be. And you can draw it in exactly the same way that you did before. And you can see that's going to repeat there, and that's where so we've got one period there. Okay, and you can also continue it all the way along for all those other values of x. Okay, 2 more slides. Okay, the range here is all real y. The period is pi. So the only real difference between y equals 3 tan x and y equals tan x is that 3 at the front, which is going to make it a little bit, which is going to make it more I guess steeper, stretched out a little bit more. So we put our pi there, because that's our period on the second marker. Pi on 2 would be there. And we're going to have exactly the same asymptotes as y equals tan x. Because it's the same as y equals tan x, it's just been times by 3. The times by 3 means every y value has been times by 3. So that's why it's going to be steeper. So we've just got that bit there, etc. I should have put this in. 1 pi on 2, 2 pi on 2, 3 pi on 2, and 4 pi on 2, which is 2 pi. Okay. And that was that value there would be negative pi on 2, negative pi, negative 3 pi on 2, negative 2 pi. And there's another part of it. Okay, so actually, you know what? I think we might try and make it a little bit steeper. Oh, actually, let me keep that there. If we say the red graph is y equals tan x, maybe we'll draw y equals 3 tan x in purple, making that a bit like that. So see, it's got the same asymptotes, same x-intercepts. Ooh, that one was wrong. This is supposed to be getting steeper down this way. Ooh. And you can see I missed that x-intercept there. Not very good. There, so it's steeper. Okay, so purple is y equals 3 tan x. That's okay if you need to draw those intermediary graphs in between. Just, yeah, colours help, and obviously labels. Alright, y equals tan x, very similar to, y equals negative tan x, very similar to y equals tan x, but that negative means all the y values are times by negative 1, or you could just say it has been flipped or reflected about the x-axis. So the intercepts and the asymptotes are all going to be the same. So that value there would be pi on 2. That looks like it rubbed out. That should be pi on 2. That's pi. 3 pi on 2. 2 pi. Going back the other way, negative pi on 2. Negative pi. Negative 3 pi on 2. Negative 2 pi. Putting in our other asymptotes. And remember, this time we are reflecting, I think I said, reflecting about the x-axis. So we are going to be going this way instead. So the y values will become times by negative 1 of the original function there. Okay, so that's y equals, accidentally pressed a button there. That's y equals negative tan x. Graph. Last graph, y equals 2 tan x on 2. The period is going to be pi on half, which is 2 pi. We'll put our period marking on the second one again. 2 pi, which means that one's pi. That one would be negative pi. That one is negative 2 pi. Obviously, the next marker along there would be 3 pi, and that's 4 pi, etc. So you can see then the way that you were going to work out the asymptotes all the way along there. I think dots work a bit better on here for the asymptotes. That 2 there, remember that number at the front is just going to stretch it up. Every y value is going to be times by 2. Alright, so you can probably draw a little bit steeper if you want. It's going to be going like this. Okay, etc. And something I didn't point out about the tan graph is these x-intercepts here, very different to y equals x cubed. Y equals x cubed has a horizontal point of inflection. It goes horizontal right there. Whereas tan x does not have a horizontal point of inflection. So making sure when you are, if you are drawing one of these graphs, y equals x cubed will go horizontal at the x-intercept, but tan x doesn't. Okay.